All right, today we're going to talk about growth, decay, and interest word problems. So there are going to be some formulas that you have to know. Exponential growth and decay, we've actually talked about this in Algebra 1, so it's just kind of our job to hopefully get you to remember it. If it's a growth, then it's A equals P parentheses 1 plus R, close your parentheses, raised to the T. If it's a decay, the only thing that's different in that formula is the plus changes to the minus. A is your final amount. P is your initial amount or your starting amount, whatever you want to call it. R is your percent rate, but there's a catch because your percent rate has to be written as a decimal. Super important. T stands for time. If they ask you to find the growth rate, that's 1 plus R, whatever that works out to be. And the decay factor is 1 minus R. So let's get started with our first problem. Okay, what I do is I look for a keyword in the problem. And in this problem, the keyword I see is increase. And increase tells me that it's a growth. Now, part A is asking for the growth factor. So GF for growth factor. Growth factor is found by doing 1 plus R. So let's talk about R. R is your percent, but your percent has to be written as a decimal. So remember the decimal place is behind the 2, and you have to move it over 2 places. So that means our R is 0.02. So then my growth factor would be 1 plus 0.02, which makes my growth factor 1.02. Okay, part B, it says write an equation. Okay, so the equation is A equals P parentheses 1 plus R raised to the T. Okay, so A equals starting amount. Well, what was the population? It started at 260 million. Now, you don't have to write all those zeros behind the millions because we can just slap the word millions on our answer. So yay for that. And then inside, we already did 1 plus R. That was the growth rate, which was 1.02 raised to the T. There's my equation. Now, part C says use your equation to predict the population in 2001. Well, we got to figure out how much time has went by. Okay, so what year did we know the population? So 2001 is what we wanted. We know the population for 1994. So how many years have gone by between there? And that is 7. So now we're going to take 7 and plug it into our equation for the letter T. So when I type that into my calculator, I get about 298.65. So I'm going to say about 298 million people. Okay, part D. In what year will the population reach about 281 million? So this time I'm giving you the final answer. So we're going to plug the final answer in. So 281 equals 260 parentheses 1.02 raised to the T. And our job is to solve for time. So the first thing I want to do is I want to divide the 260 away. And when I divide that away, I get 1.0808 equals 1.02 raised to the T. So now, how do you get rid of the T from the exponent? And you're going to say, well, hey, from the last lesson, I remember that if I put a log on both sides, I can move my exponent down to a big number. So I'm going to put log on both sides, and then I get to move my T out in front. Okay, and then if I want to solve for t, I just have to divide by log of 1.02. So then if I type that into my calculator, I get the time to be equivalent to about 4 years. But it doesn't ask me how long. It says, what year will that be? So once again, what year do we start in? We started in 1994, so add 4 to it. So it'd be in the year 1998. Done. Okay, number 2. Keyword. Looking for a keyword. And I will notice here that the keyword is less. Less means decay. Plus, if you look at part A, it says write an equation for the depreciation, which depreciation means decay. So A equals starting amount, which was 15,000, parentheses 1 minus 10% as a decimal. 10% as a decimal is 0.010 raised to the t. So if I simplify that down, whoopsie, 15,000, parentheses 0.9 raised to the t. Boom. How much will it be worth in 10 years? Well, just plug 10 into your equation. So 15,000, parentheses 0.90 raised to 10. Type that in your calculator. This time we're talking about money. So if I'm talking about money, make sure you round out to some change. So I'm looking at $5,230.18. Okay. How many years will it take for it to be worth 9,000? So 9,000 is our final. So that goes in for A equals 15,000, parentheses 0.9 raised to the t. So we're going to divide by 15,000. So then we're going to get 3/5 equals 0.9 raised to t. Put a log on both sides to get that exponent down. So log 3/5 equals t log 0.9. Then we're going to divide by log 0.9. And then I'm going to get t to be equivalent to about 4.8 years, roughly. All right, now let's go to the interest problem. So on the back, we're going to talk about interest problems, and we got 2 equations for interest. Okay, for interest, we got compound and continuously compound. So my first one here, this is where it says if it's compounded quarterly, compounded daily, compounded monthly, compounded something is my first equation. And then if it says compounded continuously, so if it says the word continuously, that is my second one. So my first equation, A is still the final amount, P is still the initial amount. And then we have parentheses 1 plus R, still rate as a decimal, divided by N. N is the number of times it's compounded in 1 year. So if it says annually, you would put in 1. Semi-annually, you'd put in 2. Quarterly is 4. Monthly is 12. And daily is 365. Close your parentheses, raised to N times time. Continuous formula is A equals P times E raised to the R times T. So once again, we're looking for keywords in the problem. So if I go look at my first example, I'm going to notice that it says the keyword compounded continuously. So compounded continuously is the A equals PERT, or what I call PERT formula. It's the PERT formula. So we got A equals starting amount, which is $12,600. And then we have the letter E, raised to, now my percent, make it a decimal, so 0.032, times our time, which is 12 years. So then I just go and I type that into my calculator. And once again, we're talking about money, so I round out to change. And so I get $18,498.63. Okay, the next one. If I look at this one, I'm going to notice I have the keyword quarterly on part A. And then on part B, we have the keyword monthly, which means this is my first formula. So A equals starting amount, 5,000, parentheses 1 plus 4% as a decimal is 0.04, divided by, first time we're going to do quarterly, and quarterly means 4 times a year. So plug 4 in for N, raised to the N, which is 4, times how long? How long are we doing this for? 3 years. Now, when you're doing this in your calculator, I would go ahead and put the 4 times 3 inside parentheses after you hit the exponent key. So everybody wants to type it in exactly how I have it written, if you use the calculators that I have at school. And I came up with $5,634.13. And then part B for monthly, the only thing that's going to change in the formula is the N. Monthly means 12 times a year. So this time we're going to put 12 in for N. And then once again, type this into my calculator. And I got $5,636.36. And that's all, folks.